Okay, for the second part of 2.5, we're still looking at making predictions. This time we're not, instead of just looking at the line and estimating using the line for the values on the grid, we're actually going to find the equation for the line of best fit. It's called the regression equation. Today we're going to do it by hand in section 2.5. We will also use the calculator function to find that equation later on in section 2.6. So here's what we're going to look at. We're looking at the age of a person, and this is their average heart rate beats per minute. I already have a line of best fit drawn on there, just so we're all looking at the same line. Now, when you're asked to find the regression equation, this is the same work as you did in section 2.4. You need to find your slope, you need to find your y-intercept. Now, one thing I'm going to caution you for is don't just look at the y-axis for your line of best fit. Some cases you will be able to do that. In other cases, if you have a false scale, meaning it doesn't exactly start at 0, it might make it a little tricky. Like in this y-axis here, we have that false scale where it goes from 0 right to 40, and then 45, 50, 55, 60. Okay? Sometimes that can make it a little tricky if the x-axis has that false scale. So the work I'm going to show here, this is the work I'm going to be grading. Like I said in the last part, everyone's line of best fit might be a little different, so unfortunately everyone's equation is going to be a little different. Okay? The line I have on there, that's what I'm going to start with, and the first thing, you need to find 2 points to find your slope. Now you want to find nice points. Okay? So when I say nice points, I mean you want to find points that go right through the crosshair. Remember, we don't care about the plots anymore. We use the plots a lot to draw the line of best fit. Now all we care about is the line. So yes, this point right here at 60, 45, that point goes right through a crosshair, but it's not on the line. The line's a little bit above it, so I don't want to use that point. Okay? Points I would want to use, maybe that point right there at 45, 55 would be a good point to use. Okay? The point, say, right here, where we're at 35, 60 would be good points to use. You don't want to use a point, say, up here. 2 reasons. One, it's kind of far away from the data. We're getting a little iffy. But also, you have to estimate. 70, 75, 80. So that might be 80. 77, maybe 78. But you have to estimate. Okay? So that's the point you don't want to use. Use points that go right through the crosshair. And sometimes you might have to estimate a little bit. I mean, if the point is not exactly through a crosshair, you might have to fudge them a little bit, but it's not the biggest deal in the world. But do your best to find points that go right through those crosshairs. So there's my 2 points I'm going to use. We're looking at 45, 55. And then the second point, or the point up here, is going to be 35, 60. Now, when we're finding slope, I want you to use the formula, because if you're just going to use the 2 points, unfortunately, since the scales are different or could be different, counting up and over might be a little trickier. Use the formula, and that's the work I'm going to want to see. This actually will work out because each one of these is counting by 5s, but I'm going to go through the work anyway so you can see what I'm expecting of you. So going through this work, 60 minus 55 divided by 35 minus 45. Okay, so that's just y2 minus y1 divided by x2 minus x1. And we would have 5 over negative 10, which is negative 1/2 for our slope. Okay, that makes sense. Think about it. We have a negative slope, our line's going down, so that all makes sense. To find our y-intercept, you can pick either one of those 2 points and work through that to get that answer, then to get your b for your y-intercept. So y equals mx plus b. I'm going to use the 35, 60. So I'm going to set this up as 60 equals negative 1/2 times 35 plus b. Going through that work, we're going to have 60 equals, that would be negative 17 and a half plus b. If you would want to leave it as negative 35 over 2, that'd be fine. I'm going to add the 17.5 to both sides. And we have 77.5. And if you look, 77.5 would probably be right about there. It's pretty close to where our line goes through our y-axis, so that's fairly accurate, fairly close. And our equation then, y equals negative 1/2 x plus 77.5. Okay, so that would be our equation for the regression line. Okay, and then we're going to use that equation a little more in section 2.6 to make predictions. Right now, I just want to make sure we can find the equation by hand, knowing the steps. This work is what I'm going to be grading. I'm going to look for things such as your 2 points. Okay, I'm going to make sure they're on your line of best fit. So make sure they're on the line of best fit. They're not just plots. Again, there might be points that go right through crosshairs, but that's not near the line. I want to find points that are close to the line. Okay, I'm going to look for your work to find slope. y2 minus y1 over x2 minus x1. Your work for the y-intercept, and your last part is actual equation. Okay, so there's going to be the points that I'm going to be looking for. I want to look at one more thing here. Okay, and I want to look at this. This is for baseball, stolen bases per game and runs per game for a team. I want to look at this because I want to draw my line of best fit. My line of best fit should look probably something like this. Okay. Not a perfectly horizontal, but pretty close to horizontal. Okay. And I want to look first at the equation. Okay. Said it's pretty close to a horizontal line, and the equation for a horizontal line is y equals whatever the value is where it crosses the y-axis. In this case, that's about 4.2, let's say. But there's our equation. You can't make predictions with that. No matter what x is, however many stolen bases there is per game, it's always going to be y equals 4.2. Okay, there is no x variable to plug into a horizontal line. If you're going to make predictions just using a line, think about what we did in the first video. You go to the point and go up and over. So if we want to say, predict how many runs are scored if 1 stolen base per game, or if you're at 1 stolen base per game. Well, there's the 1. If you go up and over, it's on that line. It's about 4.2. If you would then say at 5.5, or sorry, at 0.5 stolen bases per game. Here's 0.5. Again, it's just going up and over. It's still at 4.2. The x value has no help in predicting what the y variable is going to be. So this is why when you have a horizontal line, it's really not useful to make predictions in this manner, using this method to make predictions. Other things are going to need to be looked at. Okay? So from this section, you should be able to find the equation by hand for the line of best fit, and just know that when you have a horizontal line of best fit, it's not the best for an to make predictions with.